Step 5.3, model-based methods. We are looking at mixtures of normal distributions, and now we want to look at an example using real data with the vacation motifs dataset from package FlexClust, and we're using variables from the descriptor dataset, which can be seen as metric. These are the scores for moral obligation, the NEP score, and the vacation behavior score. So this is a dataset which contains now 3 variables, and some of these variables contain missing values, but the MCLUST algorithm can't handle missing values. And so we are using an omit to exclude respondents from the dataset where at least one of the variables is missing. First, let us have a look at what the dataset looks like. We can use the function pairs, which gives us pairwise scatter plots between all variables. That's the point style we want to use. And the color means we're in RGB space, red, green, and blue. And 0, 0, 0 selects the value for red, for green, and for blue should be all 0, which means we end up with black. And the fourth value gives us the alpha shading value. So we want to add transparency so we can do overplotting and see that overplotting happens. Because if you have no transparency, if you plot two fully saturated points one over the other, you don't see that there are 2 points. To get a feeling of density being plotted, we are using transparency, and this gives us some indication where more or less points are given. So we see here that's more saturated, so we see the overplotting effect here. This is what we obtain for that data set. So again, we cannot see any density clusters in that real data set, but we'll look at the results MCLUST will give us if we ask it to cluster in it, use the BLC criterion for selecting the best model for fitting that data. We can do this using function MCLUST with the data set, and we specify we are interested in 1 to 8. So the question is one cluster even sufficient to model that data, or would we consider more? So this is now fitted, and alternatively, we look at a restricted set of models we want to consider. So by default, MCLUST considers all 14 different models of the variance-covariance matrices which are implemented. But in a model-based clustering context, that might not be that useful. So this gives us these 3 models where we're not allowing the volume to change over the different clusters, and we're also, if we have an orientation, the orientation changes, it needs to be the same, and also the shape needs to be the same. So we can see what's the best model for if we are considering all kinds of models. We get a 2-component solution with a varying volume but equal shape and orientation. And if we restrict the models, because this model won't be contained, we get 3 components, a 3-component clustering where everything's the same, equal volume, shape, and orientation. So let's have a look at the classification plot. Now, uncertainty makes plots, observation points, larger or smaller depending on how certain we are. Classification plot is more or less the same, but without that uncertainty information. So here we get our data points, also to which component would we assign them using the probability of from which component they are, and we see here the ellipsoids which have been fitted, and we see this one is different in volume than the other. So we have different volumes, but they look at the same direction, have the same orientation, so the rotation is the same, and the shape means that the ratio between those 2 axes is the same for both. You see this one is more spread out than the other one. And the alternative plot, if we restrict and we get the 3, we see they're all 3 have now the same form. The 3 ellipsoids are all identical.